Hello, so I'm Kenji Dei. I'm associate professor of the Waseda University in Japan. So this video is for introducing the architecture course series in the top SE programs. So architecture course series aims to acquire the knowledge and skills related to architecture designs. So the series is one of the most popular series in top SE and attended in every year many industrial engineers who want to improve their design skills are attended. So these courses are supported by many instructors from the academia and the industry in Japan. So this is the architecture courses overviews. The series goals is the student acquires knowledge and skills to effectively and efficiently design and evaluate the systems and software architectures that meet the given requirements. So this course consists of 5 courses in total. 3 of them are mainly for to understand the core knowledge in this series. So object-oriented software analysis and design for acquiring basic object-oriented analysis design techniques. Also the software patterns to learn how to leverage the superior analysis and design know-how on the past development. Or on the architecture design and evaluation, this is the main course in this series to student acquires a methodology for designing and evaluating high quality architectures. Also, we have 2 more advanced courses related to the architecture designs. So model-driven development to acquire the model-centric development utilizing the model transformation and code generations. And software reuse exercise. This is called the courses for acquirers development using existing asset as well as exercise. So those 5 courses compose this architecture course series. So from now, let me introduce the detail of each course one by one. So first course of this architecture series is the object-oriented analysis designs. This course is to acquire the basic object-oriented analysis and design because the object-oriented analysis design is considered as a fundamental knowledge in many top basic courses, also the many industrial development in industries. So in this course, we mainly provide the lectures for learning the object-oriented modeling language. So we use UML as an example to study how specification or structure design or behavioral design of the object-oriented systems are modeled. Also, we study the object-oriented development methodologies. So there are many object-oriented methodologies, but we choose Iconics as an example of the object-oriented methodology because the Iconics is very simple and easy to learn. So basically, the Iconics obtains the design models from use case and domain models. So by using the advantage of the object-oriented design, that is, we can use same modeling techniques to model the target domain itself and inside designs of the systems. By using the same modeling tools, so we can simply map the relation between the object in the real world as a data model inside of the system, because the system should reproduce or simulate the relationship or data in the physical world. So that's quite true to use the same terminology and this close relationship between the domain model and the data model in the systems, so system can be easily traced from the changed in the real world can be easily traced, and we can easily identify which data can be adapted according to the change in the target domains. So those types of modeling language and object-oriented methodologies the student will study. But the techniques, design and analysis techniques down here is mainly for fulfilling the functional requirement. So in the real software development situations, so developer need to satisfy not only the functional requirement, but also the quality requirement as well. So to improve the quality requirement, it is the one of the efficient way to do that is the run, how to leverage superior analysis and design know-how obtained from the past development. So in some cases, so experts have already identified the good solutions for the similar problem you faced. So by using the know-how obtained the past good practice, so the developer can easily apply existing knowledge on analysis and design and implementations. So those know-how are modularized and documented as the patterns. So this course, software pattern, is learn how to leverage the pattern, how to find patterns or how to apply existing pattern to your software development. So, but the pattern, software patterns typically includes the pros and cons, some good advantage or disadvantage, to not only for the advantage, but also the understanding the disadvantage, such as the side effect on the given software design and analysis, need to be carefully understand. And the engineer should carefully choose appropriate patterns by considering both and pros and cons of the given patterns. So this course lets students understand the background design principle of the patterns and do many exercise on the pattern selections on how to select the appropriate pattern for the given situations. Also, the patterns are not only for the design, but also the pattern for the analysis, pattern for the design, pattern for the coding, pattern for the maintenance, pattern for the project management. So many activities related to software development. So there should be some best practice for each activities. Also, we can identify and extract minds patterns for each activities. So this course also covers how to mine the patterns. So we do exercise to make the your best practice in your project reusable for your success of the project. So third course in this course series is the architecture design and evaluation. This is the main course in the architecture course series. So this course is to acquire the methodology for design and evaluating high quality architectures. So architecture is a quite important milestone in software development. So it is not only for the designing software architecture, but also the evaluating the software architecture to identify the current bugs in the software architectures or risks can be identified by designing the architectures. Also, some ambiguities or inconsistency between the given requirements can be identified. So this course covers both architecture design and architecture evaluations. So we choose the very popular architecture design method and architecture evaluation method, like the attribute-driven design or architecture trade-off analysis method. The students studies both techniques and methodologies and do the exercise with IoT system examples. So to design the high quality software architecture by considering the trade-off among the quality requirements. So those three courses are mainly for studying the basic techniques to understand basic techniques of design and evaluating software architectures. But in this architecture courses also provide the advanced courses. One of them are model-driven development. So model-driven development is now known as the low-code development or no-code development, as many industry have the much attentions on those types of software development. The basic principle of the model-driven development is the shifting the software development abstraction level from code to models. So acquire the model-centric development. So engineers work on models. So and the code are achieved by generating the code generation techniques from the models. The engineer typically do not touch on the code, but also they can work on the models. And the model provides a good abstraction view for the problem solving. So engineer can focusing on how to solve the problem rather than how to implement by using the programming language. So the separation of concerns will improve will make the software development efficient and they make those outputs qualities improved. So this course covers not only the concept of the MDDs, so students can enjoy how software development changed by raising the abstraction level of the artifact. So by using the given model-driven development environment, so students do the exercise on how robot programs can be tested and debugged. So we choose the robot control systems. So and by using the executable UML and the Bridgepoint is a model-driven development tools and the Lego Mindstorm robots, students can enjoy how the software system can be debugged on models. But also in this course, so we do some lectures and exercise to how to develop such a model-driven development environment itself. So sometimes the high-skill engineers, they required to set up its own development, a model-driven development, or their business or the product domains. So in that case, it is very difficult, but the engineer is required to automate the transformation from model to code. By those transformation typically done by the developers themselves, but by reusing the knowledge on the transformation from model to code and make them as a rules, so the translations can be automated. So this model transformation exercise can work on the model transformation rule language, called ATL is the de facto standard of the model transformation rule language. And they try to develop the model transformation rule to automate the transformation from the highly abstraction level model to the lower, more details levels models, including code. So typically, this model-driven development exercise uses the Lego Mindstorm robot. We use a physical robot and we do the in-person exercise with the real robot in the rooms in the NIRs. So, but unfortunately, it is not support. The online support was not supported, was not available by 2019. But we faced the COVID situations. So we migrate the exercise environment on the physical world to the on cloud. So we developed the 3D simulator on AWS to perfectly reproduce the same behavior of the physical robot on simulators. So we support online exercise with the simulator developed on top of the Unities and it is deployed on EC2 on AWS. So from 2020, so we support online exercise by using the 3D simulator on AWS. So The last course is the software reuse exercise. So far, the students have studied a couple of reusing techniques, including, for example, patterns, but there are many other types of reusing techniques for supporting software development, such as document reuse, use case reuse, pattern reuse, framework reuse, component reuse, product line reuse. So those many types of reusing techniques can make the software development efficient. So this exercise course covers different types of reusing techniques. So only this course is provided in a flipped classroom styles. So students are expected to check the lecture material in advance of the class, and during the class, students only do the exercise. So the exercise covers diverse reusing topics. So that is all for the object architecture course series. So there are a couple of dependency between courses, but typically the student will take the object-oriented analysis and design the first because it provides a fundamental knowledge for other courses. And if students want to improve their architecture design skills, the students are expected to take software patterns and model architecture design and evaluations. And if the students are interested in the development in the embedded system or low code or no code development, so model-driven development are highly encouraged to take. And so students also improve not only the architecture design, but also in general designing techniques. So software reuse exercise will be provide a good exercise to improve their designs and analysis and design and implementation skill as well. That is the overview of the architecture courses. Thank you for listening.